Hello everyone. I am Mrs. Pranjali Safle. Welcome all you in MSBTE approved fifth day of STTP on Environment Engineering for Global Sustainability organized by Civil Department of SIOT Kharghar, Navi Mumbai. It's my pleasure to introduce our today's speaker and a great personality, Mr. Ravindra Thakur sir. Mr. Ravindra Thakur sir has a vast experience of more than 30 years in water, wastewater engineering, and solid waste management. Thorough understanding of various current norms and specifications, he has been involved from the planning, executing, and operational stages of various projects. He has also been involved in the detail engineering for rural and urban water supply drainage schemes with a thorough knowledge of drawings for various projects. He has also been involved in various water supply projects like planning, designing, construction of 300 MLD capacity of water treatment plant for SIDCO and Navi Mumbai Municipal Corporation area. Sir involved in operation and maintenance of 280 MLD capacity water treatment plant project of Shah Temgar Water Treatment Plant Authority in all respect. Sir associate with the Maharashtra Jeevan Pradhikaran Mumbai from February 1991 to October 2020. In this capacity, he was involved in the guiding of team of engineers and planners of various technical and design issues for the projects undertaken by the Maharashtra Jeevan Pradhikaran along with the leading the execution team on many critical aspects. He worked at MGPS Central Planning Monitoring and Designing Unit for nearly 4 years. Here he technically scrutinized the proposal of water supply, underground drainage system and municipal solid waste management received from urban local bodies to CPDM office. Technically, he scrutinized nearly 250 projects and saved nearly rupees 800 crore. Currently, sir, working as a assistant vice president of Choice Consultant Private Limited. Now, I would like to invite Mr. Thakur sir to proceed for the further session. Sir, please.
Thank you very much, madam, and good afternoon, everybody. Madam has given my introduction thoroughly. Now I'm going to start subject directly. Uh, my subject is today fecal sludge and septage management in rural area. This is a very burning issue. Fecal sludge and septage management in rural areas, it is very burning issue. Uh, we I'm going to for introduction of the subject first. Uh, India has undergone urbanizations as compared to other countries in the world, and very less population is living in urban area and than rural area, and urban centers are experiencing very hard uh, facing very difficulties in the municipal services such as drinking water, access to toilets, and safe management of solid waste, grey water, and fecal management. Similarly, rural area also could not provide this facility because lack of funds, lack of manpower. So, according to census of 2011, less than 20% of urban household had no access to toilets. However, only 33% of households were connected to sewers and 38% were connected to septic tanks. In rural area, it is found difficult to provide adequate services such as drinking water, access to toilet, and safe management of solid waste, grey water, and fecal management, as I told you earlier. Taking into a comprehensive look uh, in today's position of India's sanitation position, it is a horrible position actually. 37 million so practice is a open defecation in urban India. 28 million people with individual toilets uses insanitary methods of disposal of waste, and 43,117 mld of untreated waste is discharged into water bodies or on land. It is very horrible situation because this untreated wastewater discharge in water bodies, it pollutes water bodies all the while, and it also pollutes the groundwater, and it causes pollution, harmful effects to environment also, and these undesirable changes to ecosystem, reduction in economic value of resources, aesthetic damages, human health risk. Contaminant of concern that are present in the water include pathogens, nutrient heavy metals, suspended solid, and increases biochemical oxygen, biological oxygen demand, and oil and grease. All these wastewater should be treated properly, or in future we will face very difficult situation. So government has uh, government has introduced taking initiatives to uh, 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 government has introduced so many schemes uh, to introduce to treat the wastes, and to provide the facilities to the uh, people. So previously, manual scanning was done uh, in uh, in a rural area and urban area also, and but government has introduced some government made some laws and amendment that manual scanning should be stopped properly, and uh, it should be it should not be handled manually, and there was a act formed in 2013 in which even cleaning of septic tank, gutters, and sewer, which involve directly contact of person with waste, is not allowed. Thus, intending to put a complete end of the manual scavenging involved across the sanitation, because it was very cruel method that manual scavenging was done previously, and we are happy that manual scavenging is completely stopped, and due to government's initiatives taken. In 2014, Government of India introduced Swachh Bharat Mission, which is a flagship program with an objective to improve the sanitation situation in India. Although Swachh Bharat Mission has a lot of objective, two very important objectives pertaining to managing of human waste are eliminating open defecation and manual scavenging. Again, in some area manual screening was there, and in Swachh Bharat Mission they they start to completely stop it. Then to achieve the first objective, uh, certain indicators and guidelines were laid down under the program. No household should engage in open defecation. Firstly, and secondly, no insanitary toilets are allowed to be built, and all the existing pit latrine. Then subsequent to the introduction of Manual Scavenging Act, Government of India in 2014 took up a huge task of eliminating open defecation in India. Swachh Bharat Mission was launched, and one of its focus is in making urban and rural habitations open defecation free. To do this, the policy specifically mentioned that all households should have access to toilet in the form of individual household toilet or a communal toilet. But only creating the infrastructure in the form of toilet and contaminant system is one part. But government soon realized that maintenance of this infrastructure is very important. Without the management of the waste originating from the household and contaminant unit, the objective of sanitation cannot be ensured. So ODF plus plus was the concept was brought forward, which said the fecal sludge, septage, and sewage should also be safely managed at the local government level. Then in 2016, year 2016, FSSM fecal sludge septage management got a formal recognition in different form. Along with the national policy on FSSM was uh, government provided plenty of guidelines, standards, and resources in the form of primer and other publications. The present sanitary system. Now we discuss on the present sanitary system in urban centers. The developing countries, due to the availability of water, use of flush toilet, that is the wet systems, are the easiest to operate and maintain. Water is used to transport the waste from point to another. This system are called wet system. For this, the sewer lines were laid and the waste carried to the sewage treatment plant. Then offsite disposal system. The liquid and solid are carried away from the point of generation using a sewage network. The sewage network brings the waste from a mini city, the households, to one point where a wastewater plant is set up. This is called the sewer sanitation, that is offsite. Then on-site disposal system is the solid are stored in the containment unit and the liquid effluent is disposed of into the ground using soak pit or soak away. After a duration of few years, the contained solids are emptied and transferred to the further treatment. Since this conveyance of solid is done by mechanized equipment such as vacuum trucks, this type of sanitation system is called non-sewer system. In rural area, it is not possible to lay the sewer line to take the wastewater to the treatment plant, so the vacuum trucks are used. Then in some area, hybrid disposal system is used. In India, the solids are contained in the septic tanks at the household level, and the sludge is disposed of into the drains outside the houses. The network of drain collect the sludge from all the household, and by gravity it bring to the surface water body such as river, lake, and pond. Again, we are polluting the river and lake by delivering the sludge into this river, lake. Then the septic from the septic tank is emptied after a few years and transported by vacuum trucks for either treatment or direct disposal. Since the network of drainage is involved for conveyance of the sludge, this system cannot be classified as completely sewered or non-sewered sanitation system. So we can see here disposal systems are should be properly designed, or otherwise our water bodies and ecosystem balance will be collapsed. So what is fecal sludge and septage? Actually, all liquid and semi-liquids contain of pits and wall accumulating in one site sanitation installations. It has a high BOD and total solids, total suspended solid and total dissolved solid than the wastewater. Fecal sludge actually is fresh and yellowish, higher having higher by BOD, needs high degree of treatment. Then septage is a well digested and a blackish sludge having a lower BOD, need a lesser degree of treatment. Okay. And most of the city are not having FSTP or STP for treating the wastewater or septage. Hence, in absence of proper disposal point, the septage is indiscriminately disposed of in the surface water bodies. I explained in previous slide, there are more pollution and health hazard when compared to the open defecation. There are no regulation at the ULB level for a proper disposal of fecal sludge septage management in absence of a treatment facility. Since the solid content of fecal sludge and septage significantly high when compared to the wastewater, indiscriminate disposal of it possesses a bigger health hazard. As a precautionary measure, the ULB should at least practice scientific land disposal to reduce the spread of the pollution. So government has given strict guidelines that fecal sludge should not be disposed in the river or disposed on the land, and take proper actions and precautionary measures to avoid further health hazard or ecological balance. Actually, in cities, that this type of treatment plant is available, and all the sewage is collected from the sewer lines, which are laying in a proper slope, and it uh, manifolds, from manifolds to property connections to trunk main, and collection of sewage is properly done by giving the proper slope to the all the sewer lines, so that it will be flow by gravity to the uh, at the site of the STP. Then here bar screen are there to screening of the sewage. Then here equalization septic tank is there. Then here primary settling time, from equalization settling time, the water goes to the primary settling time. Then primary settling to aeration settling time. This is the actually urban. This is actually I'm not discussing it in detail because this is for urban area, and very costly system is there, because for this uh, sewer lines to be laid properly, and to avoid such huge cost of the STP and a huge complex system. Government has introduced some specific treatment which are not costly, which are less costly and require less space, and they are not required to lay the sewer lines. So these all these systems are used by the rich ULBs, those who can afford their maintenance, those who can take their funds, because the government is not giving 100% the fund to the ULB under urban local bodies to construct all these sewer lines and the STP. Government, as per their category A, B, C, there are categories in ULB. So government issues some government issues fund to them, but they have asked to put their contribution also, and municipal corporations, urban local bodies have to put their contribution against the 100% funds are not provided by government. 80% funds are giving, 65% funds are giving, and other part should be borne by the urban local bodies. So in rural area, in some rural part, uh, they could not borne this huge cost. So instead of going for this complex and costly system, government introduced very simple and maintenance less, which required less maintenance. So uh, actually, first we should take a look of this slide. Uh, 77 in total. There are 250, 3, 330, 393 ULB are there, and category A cities have 70. There are 77 ULBs which has their co-treatment at their own STP. They have their own STP in 77 ULB in Maharashtra, and in category B cities from Maharashtra, 64 ULBs treat their treat their wastewater within the 20 kilometer of nearby 20 STPs nearby them, and remaining ULB they have independent FSTP, and or they are treating nearby FSTP. Here STP and FSTP. Government now government take initiative that instead of giving STPs to every ULB, fecal fecal sludge treatment plant are very easier to operate, and it has very less cost than the STP providing STP. So we'll go in the next slide. Uh, Benefit of fecal sludge and septic management. Discharging frequency, we have to decide a discharging frequency. In what manner we can go the what are the treatment actually suggested. We are going in the next slide. Firstly, we should study this slide. Discharging frequency as a regular service. Discharging done on a fixed cycle of 3 years and predetermined schedule. Actually, in fecal sludge treatment, uh, every household has a septic tank, and after every 3 year, that septic tank should be get clear by vacuum truck, and that the sludge should be carried for the treatment. So after every 3 year, that septic tank should be clear. Then environment benefits, likely reduction in BOD and coliform in the septic tank effluent due to better efficiency of tank, also avoid solid overflow. Environment benefit, FST, अगर हम if you are providing FST, fecal sludge treatment plant, then environment benefit that uh, after treatment, the BOD of that waste reduced considerably. That is less than 30 mgpl, mg per liter, and coliform get completely removed, and that effluent can be used for the gardening purpose or any other then equity and affordability, all the properties covered, lower prices due to the trip optimization and assured business, local tax. So uh, these system are very affordable system, and ULB can take tax from the people to run the system, uh, or to recovering the OPEX or operation maintenance cost. Then the regulation and monitoring. Regulated monitoring by ULB removes need from manual labor due to regular emptying. So these benefits are are seen when fecal sludge treatment plant management are properly done. So in a kit fecal sludge treatment plant having key treatment components, that is solid liquid separation and liquid treatment units. Then third one solid treatment units, and fourth one disinfection unit plus reuse and disposable. Actually, there are various septic management options are available. Group A septage component, sedimentation ponds first, then sludge drying bed, in which planted sludge drying bed and unplanted sludge drying bed are also there. Then co-composting, then mechanical dewatering, and then waste stabilization point, and advanced nutrient recovery. This is the group one. And now group A and group B, biomethanation and anaerobic biogas reactor, and incineration and gasification and pyrolysis. These are the grouping done by uh, FSSM people, and which are the beneficial to the rural area. They have decided. Uh, the group B is very costly, and therefore in Maharashtra In Maharashtra, these four FST, fecal sludge treatment plants are introduced and approved by NIRI. These four treatments means one is sludge drying bed, another is a planted sludge drying bed, and fourth one is upload anaerobic sludge blanket, and sorry, third one is upload anaerobic sludge blanket, and fourth one is moving bed bioreactor. So uh, physical chemical characteristics of septage are given here. Normally, the biochemical oxygen demand is the range in between 400 to 78,600. Then chemical oxygen demand is, sorry, uh, for a minute, please. Sorry, there was a call from urgent call for my boss. And total solids range is uh, 1,132 to 1 lakh 30,745. All these are the ranges of the physical and chemical characteristics of the septage. And we can see here uh, type A means public toilet or bucket latrine sludge. And here type B, that is septage. And after 2 to 3 years, the you can see here in a public toilet, if we see COD is 20 to 50,000, but after septage means several years, we can see here it is less than 15,000 COD. Then BOD also get in decrease here, and total solid and suspended solid, that's also decrease in when that sludge get after 3 to 4 years. We can treat this septage. Okay. And as per MSW rules, the content of the concentration not to exceed the prescribed limit are given here. Arsenic should be up to 10 only. Cadmium for up to 5 only. Chromium, all these are parameters in MSW. And dewater septage sludge are used as a fertilizer. The fecal coliform density should be less than 1000 mpn. Then uh, Thalamonal specific density shall be less than 3 mpn, and E. coli of 1000 gram per total solid. All these are the standards, quality standards. If we want to use the uh, treated sludge. Properly treated sludge can be used to reclaim perched land by application as a soil conditioner and or as a fertilizer. Deteriorated land areas which cannot support the plant vegetation due to the lack of nutrient, soil organic matter, low pH, and low water holding capacity can be reclaimed and improved by the application of treated septage. Then, in this today's lecture, I would like to simple describe in brief give all these four process. And before selection of the technologies, uh, all these five components are very necessary. That is a land requirement, electricity requirement, management capacity, fund requirement, and real fund conditions. So before selection this technology, this should be studied. All 5 points should be studied first. Then I told you in previous slide that four technologies introduced by government of Maharashtra. Uh, so every rural body or urban local body could not bear USB or MBR, so they can go for unplanted or planted storage drying bed, because here we can see land requirement is relatively high, and in rural area the land can be easily get available, but in urban area land is very land issues are very much high, and so USB and MBR are required less space, so they can provide USB and MBR. Then electricity requirement in rural area, they have low electricity. There is some in some area, rural area, we are still facing some electricity problem, and electricity based technologies, STPs, FSTP cannot be offered by rural area, but uh, urban local body uh, have continuous electricity supply, and they can afford by applying the taxes. Then management capacity. Actually, in rural area, there is the lack of human source. Human source is not properly there. But in urban local bodies, they can employ the private contractors, or they can appoint their staff. It will not affected by rainy season, because they are uh, very compact systems. Directly going to the systems. We are using the four system, the four FSTP system. That is, first is the unplanted sludge drying bed. Uh, Here, septage is collected by vacuum truck from every household, and then that trunk that truck is emptied in the settling tank having the screen, and then after here the screening is done, the floating matters will be removed, and then unplanted and that sludge is moving to the unplanted sludge drying bed, and after pouring the sludge in this bed, the water gets the water the liquid liquid from wastewater from this bed goes to the anaerobic baffle reactor. This anaerobic baffle reactor is nothing but a improved septic tank. It has a it is a chamber, it is a RCH chamber, and having baffle walls, and that water is the water force all kind of wastewater to flow under over of the baffles, and it is the wastewater introduced the chamber of, at bottom, leading to the enhance the contact with the biomass in the baffle in this tank, aerobic baffle reactor. Then due to increase in retention time and of wastewater, anaerobic degradation of a suspended and dissolved organic matter pollutant is take place here. Here the uh, sludge settle down, and after water goes after traveling of water from this baffle walls, here beauty of the wastewater decrease 60 to 80% in this reactor, and that water allowed to flow to the horizontal planted gravel filter, and this and water pass through horizontal allowed to pass through the horizontal planted gravel filter, and then it connect to the polishing point, and in polishing point the water hold for 2 to 3 days, uh, and ultraviolet the ultraviolet from sunlight it get clear, and then this can be used for the gardening purpose, or any uh, some normally we are using a gardening purpose, so many of other users are not people are not there to use this water, in spite of we show them this water is not having E. coli or not having any order, but people are hesitating to use this water, and but what is the gain here, that wastewater is properly treated and then disposed to the can be disposed to the lake, or can be used for the gardening purpose. Okay, so uh, here liquid treatment is done in ABR, and solid treatment uh, solid treatment is done in the unplanted sludge tank bed. After sludge get dried, that has been removed, and it is a used as a fertilizer. After 10 to 15 days, the sludge removed from the unplanted sludge tank bed, and can be used as a fertilizer. In Bhubaneswar, Odisha, this type of plant is installed. It has a capacity of 75 KLD, and capital cost was incurred rupees 285 lakhs, and for this plant they required 19.25 lakhs per annum for operation maintenance, and it was situated in the 10,000 10,117 square meter. This plant was commissioned in June 2018 and still properly operated by private operators. Uh, Now you can see here the plan, the, the truck discharge here, the uh, fecal sludge here, then through the channel, it's go to the unplanted sludge drying bed, and from the sludge drying bed, it goes to the anaerobic baffle filter, and from anaerobic baffle filter, it goes to the horizontal gravel filter. That then clear water sent to the polishing point. This is the uh, elevation that we can easily understand. And in this unplanted unplanted drying bed, the sand there are uh, various layers of material are provided in the sludge drying bed. First, sand layer was there 10 centimeter. Then gravel layer was of 10 centimeter, and gravel of bigger size of the 10 centimeter. That's 40 centimeter of the material is there, and fecal sludge of the 30 centimeter layer can be adapted here. Then total this is the total depth 0.8 is allowed here, and the water is collected from here and allowed to send in the ABR. All complete system is by based on the gravity flow system. No need of electricity here. Only they have to maintain the these units to be properly at level, so that gravity flow can be maintained. So no need here electricity use is 0%. No irrigation required. Nothing is required, and we get the clear water in polishing point. And after 10 to 15 years, we get here the digested sludge and can be used as a manure. Now here, second is planted sludge drying bed here. It's simply simple changes here. In previous system, unplanted sludge drying bed was there, and here the sludge drying bed here in this sludge drying bed, the plants are there. You can see here the, the plants are there, and these plants also have a role to reduce the beauty of the water, uh, and and take part in the digestion of the organic matter in the wastewater. Okay, and same thing here. The liquid is allowed to liquid is sent to the anaerobic buffer reactor here, and the solid is the after drying, the sludge sent for the platform for drying the manure, drying as a manure, and used for disposal. And here, after the water allowed to pass through the anaerobic wastewater allowed to pass through the anaerobic buffer reactor, considerable BOD wastewater BOD reduced, and this here again that what is allowed to pass from horizontal plant gravel filter. Then uh, after gravel filter water passes, it will collected in the tank, and that can be allowed for use purpose. Sometime here chlorination is also allowed if that water is used for the another purpose, like car washing, or some people want to take it out. People are allowed to take, but chlorination should be done, is mandatory here. Now this type of FSTP is uh, at a Leha area and Kulana. In Leha, 12 KLD plant was there. Plant is situated. Uh, Plant is constructed. Sorry, and land required for land required is 720 square meter only, and capital cost was involved rupees 52 lakhs, and operation maintenance cost rupees 10 lakh per year. And it was commissioned in 2017, and it is still working. Uh, Actually, uh, after every system, I would like to show these plant to you, because these technologies are not only on the paper, but they are already executed at the site. So I'm in the interest to show all these cost and all these the photos to you. Okay. Now, off-flow aerobic sludge blanket. I already told you this is the costliest technology, FSTP type of FSTP, and this can be offered only by the rich municipal corporations, which they can share their contribution toward the money spent on the construction. So it is what it has. It has a septic from septic tank again, that can be collected from the vacuum truck. Then screen at gate removal was taken here. Okay. Then collection tank here. Then water collected. Then it will go to the clarifier for settle down. Flocculation take place there, and then it is sent to the USB reactor. That is the upflow anaerobic sludge blanket constructed here. It has a typical construction, so, and uh, I cannot. My time is not permitted me to explain in detail. But if I got some another uh, in another lecture, I may explain you in detail that USB, what is the USB and how it work. Okay, that after here also solid part is uh, in USB, and liquid part is uh, uh, treated in anaerobic reactor. Both are actually in USB also. Water can be treated here, and for further because this USB decreases the BOD up to 60 to 70%. And if USB followed by anaerobic baffle reactor, then again BOD decrease up to that 10 here we get to decide a value of BOD, which can decide value of BOD of the wastewater, which can discharge into the river, or we can use that wastewater. Then uh, the sludge coming from sludge collected from this uh, system is again again allowed to uh, at unplanted sludge drying bed, and after 10 to 15 days that sludge can be reused. And here also, after the uh, water get water allowed to pass through anaerobic baffle filter, that can be uh, uh, allowed to pass through activated pressure filter, pressure sand filter, and activated carbon filter, so that the water clear water can be there. Water should be quality of water can be improved here by giving SCF and PS when allowed to pass through SCF and PS, and water can be used here. Okay. Then USB USB system is installed in the Sinnar. It has the capacity of 70 KLD, and uh, land was there. The plant situated in the 1547 square meter land. Capital cost was involved 1 crore 163 lakhs, and operation maintenance cost was 8.3 lakh per year, and it was commissioned in 2019. Recent plant is there. It's a very good plant. If anybody is interested, can go and see. It is working very finely, and the affluent was also very good, and it met to the standard which has been set by MOEF. So that can be very achievable, appreciable work done by the Sinnar Corporation, Sinnar Council. Then another is the plant that's a Cochin. It has capacity of 100 KLD, and land required for this is 1,200 square meter, and capital cost was 275 lakhs, and it has a huge O&M cost required because its capacity is higher. So here required 24 to 30 lakhs per year as compared to the uh, Sinner, because there are the cost different different parameter are there why the cost is low, operation cost is higher or lower. So uh, now moving bed bioreactors. This system is this type of FSTP is also running very well, and in this moving bed bioreactor is used. Uh, Here also BOD is reduced considerably. The flow diagram is sep- septage from the septic tank, then allowed to the collection with the screen here, and after screening the solid liquid separation unit is there, and after solid and liquid separation unit, it has been sent to the liquid is sent to the MBBR package unit. These package units are available, and these package units can be manufactured by the manufacturer as per our capacity, our required capacity, from 1 10 KL to 200 KL, they can be constructed. This plan, uh, it's working also. I'm interested to tell you the working of this MBBR, but time time doesn't permit me. So I will discuss in next lecture if I got chance. Okay. Then in this MBBR unit, the water is treated, and this is the attached growth type system, and water is treated here, wastewater is treated here, and then it is used for then it can be used for a disposal. It can be reused or can be disposed safely in the river or the lake. Okay, so all these four systems are there. This MBBR type is installed in Ambikapur, Chhattisgarh, having capacity 5 KD. And I think work is not completed yet. And commissioned in 2017, and its capital cost involved was 23.35 lakh. It was very short, very small plant, 5 KD, and operation maintenance cost was rupees 2.5 lakh per year. Okay. Now I have some videos when we visited to the site, that you can very well understand from this video. And from my side, uh, it is over. Then I would like to show you the videos regarding the FST. Okay, please.
नमस्कार दोस्तों, मैं हूं श्याम। मैं एक फीकल स्लज ट्रीटमेंट प्लांट या एफएसटीपी का ऑपरेटर हूं। आज मैं आप सबको अपने काम के बारे में विस्तार से बताऊंगा। तो तैयार हैं आप? जैसा कि आप सब जानते हैं, भारत सरकार ने 2014 में स्वच्छ भारत मिशन की शुरुआत की थी, जिसके अंतर्गत शहर और ग्रामीण इलाकों में बहुत बड़ी संख्या में शौचालयों का निर्माण हुआ था। मगर क्या सिर्फ शौचालयों के निर्माण से स्वच्छता सुनिश्चित हो सकती है? बिल्कुल नहीं। शौचालयों से निकले मल का सही निपटान स्वच्छता को सुनिश्चित करने के साथ साथ समुदाय को एक बेहतर जीवन की ओर अग्रसर करने के लिए जरूरी है। और इसीलिए स्वच्छ भारत मिशन के दूसरे चरण में फीकल स्लज मैनेजमेंट या एफएसएम को केंद्र बिंदु में रखा गया है। एफएसएम मल निष्पादन का एक किफायती और साधारण विकल्प है जो शहर और गांव दोनों जगह लागू किया जा सकता है। एफएसएम और उससे जुड़ी प्रक्रियाओं को और अच्छे से समझने के लिए आज हम आपको पतौरा ग्राम पंचायत लेकर आए हैं, जो छत्तीसगढ़ के दुर्ग जिले में स्थित है। यहाँ पर छत्तीसगढ़ का पहला एफएसटीपी हाल ही में बनकर तैयार हुआ है। वाटर एड, जिला पंचायत दुर्ग और ग्राम पंचायत पतौरा के संयुक्त पहल के कारण आज ये संभव हो पाया है। सॉइल टेस्टिंग जैसे वैज्ञानिक मूल्यांकन के आधार पर इस एफएसटीपी के लिए उचित स्थल का चुनाव किया गया है। इस प्लॉट की कुल क्षमता 9000 लीटर प्रति सप्ताह है, जो कि 3 ट्रक लोड मल के बराबर है। यहाँ ट्रीटमेंट प्राकृतिक संसाधनों एवं ग्रेविटी बेस आधारित तरीके से किया जाता है, जो कि कम ऊर्जा की मांग करते हैं और जिनका संचालन और रखरखाव कम लागत में होता है। अब इस प्रक्रिया के बारे में विस्तार से जानते हैं। सबसे पहले गाड़ी शौचालय के मल को लेकर एफएसटीपी आती है। उसके बाद उसके आउटलेट को स्क्रीनिंग चेंबर के इनलेट से जोड़ा जाता है। स्क्रीनिंग चेंबर मल में मौजूद किसी भी कचरे जैसे कि प्लास्टिक, कपड़ा, सैनिटरी नैपकिन आदि को आगे जाने से रोक लेता है। कार्य करते वक्त ये बहुत जरूरी है कि ऑपरेटर ने पीपीई किट, मास्क, ग्लव्स और गमबूट्स पहने हों और सुरक्षित तरीके से मल का निष्पादन हो रहा हो। स्क्रीनिंग चेंबर प्लांटेड ड्राइंग बेड यानी पीडीबी से जुड़ा होता है। पीडीबी मल के ठोस एवं द्रव्य पदार्थ को अलग करने का कार्य करता है। पीडीबी एक विशिष्ट उपचार प्रक्रिया का यूनिट है जिसमें अलग अलग आकार के पत्थरों की वर्टिकल सतह बनी होती है। सबसे ऊपर सैंड लेयर होती है, उसके बाद छोटे पत्थर और सबसे नीचे बड़े पत्थर होते हैं। बड़े पत्थर के साथ साथ ऊपर की ओर केली के पौधे भी लगाए जाते हैं, जो कि पानी को फिल्टर करने का कार्य करते हैं। ये फिल्टर मीडिया एक छन्नी का काम करती है। ठोस मल बेड के ऊपर रह जाता है और द्रव्य फिल्टर मीडिया से होते हुए शुद्धिकरण के लिए आगे की प्रक्रिया में इंटीग्रेटेड सेटलर में चला जाता है। इंटीग्रेटेड सेटलर एंड एनारोबिक फिल्टर एक ऑक्सीजन रहित बंद यूनिट है जिसमें दो कक्ष एक बैफल बॉल के द्वारा अलग होते हैं। इंटीग्रेटेड सेटलर एंड एनारोबिक फिल्टर में 90% तक प्रदूषकों को कम किया जाता है। दुर्गंध व रंग हटाने के लिए और दूषित जल में ऑक्सीजन की मात्रा बढ़ाने के लिए जल को कंस्ट्रक्टेड वेटलैंड में लाया जाता है। यह एक हॉरिजॉन्टल फिल्टर मीडिया है जिसमें अलग अलग आकार के पत्थरों से गुजरकर दूषित जल प्रवाहित होता है। मैक्रोफाइट या जलीय पौधों की मदद से जल में ऑक्सीजन की मात्रा बढ़ती है और जल शुद्ध करने के लिए अनुकूल जीवों को पनपने में मदद करती है। और अंत में पॉलिशिंग पॉन्ड, जहां उपचारित जल को पुनः शुद्धिकरण कर संग्रहित किया जाता है। ये जल को एकत्रित करके रखने के साथ साथ हवा और सूरज की रोशनी से पुनः उसका शुद्धिकरण करता है। पॉलिशिंग पॉन्ड में उपचारित जल का वाटर टेस्टिंग, बीओडी, सीओडी और पैथोजेंस का टेस्ट किया जाता है। पॉलिशिंग पॉन्ड के जल को खेती या बागवानी जैसे कार्यों में इस्तेमाल किया जा सकता है। और तो और सूखे हुए मल को कंपोस्टिंग या कंपोस्टिंग के बाद खाद के रूप में प्रयोग किया जा सकता है। क्या आप जानते हैं कि मानव मल को सोन खाद भी कहा जाता है? ये तो हो गया एफएसटीपी के बारे में, मगर अभी एक और जरूरी बात जानना बाकी है। स्वच्छता सिर्फ अपनी ही नहीं, अपने आसपास की भी जरूरी है और इसके लिए हमें कुछ बातों का ध्यान रखना बहुत जरूरी है। सफाई कर्मी उक्त कार्य करने के पश्चात अपने आप को सही तरीके से सैनिटाइज करें। यह एफएसटीपी एक बदलते हुए भारत का साक्षी है। पतौरा के साथ साथ आसपास के भी ग्राम पंचायतों के लिए ये एक अनमूल्य तोहफा है और मेरी तरह और भी लोगों के रोजगार, बढ़ोतरी और बेहतर भविष्य का सुनहरा अवसर है।
Now, second video is from Khopul Nagar Parishad. It is also a wonderful plant. We have visited there. Please take a look of it.
नमस्कार. सध्या आपण खोपोलीच्या फिकल स्लज ट्रीटमेंट प्लॅन्टवर आहोत आणि शासनाच्या परिपत्रकानुसार प्रत्येक सेप्टिक टँक हा 3 वर्षांनी एकदा खाली व्हायला पाहिजे. तर सेप्टिक टँक खाली करताना तो जो त्याच्यातला मैला आहे तो आपल्याला सायंटिफिकली ट्रीट करणं हे सगळ्यात आवश्यक आहे. तर ODF++च्या सर्टिफिकेशनसाठी आपला जो मैला आहे तो सायंटिफिक पद्धतीने ट्रीट व्हायला पाहिजे. तर सध्या मी एफएसटीपी प्लॅन्टवर आहे आणि इथे सध्या एक सामूहिक शौचालयाचा मैला आपण आपल्या सक्शन ट्रक थ्रू आणलेला आहे आणि तो आपण आपल्या प्लॅन्टमध्ये खाली करतो. आपली साधारण 2011च्या जनगणनेनुसार पॉप्युलेशन 71,73,000 होती आणि सध्या आपली पॉप्युलेशन ही आपण 80,000 कन्सिडर केली आहे 2020ची पॉप्युलेशन. तर त्यानुसार जो काही मैला येतोय तर आपल्या शासनाच्या परिपत्रकानुसार 75,000च्या वर जर पॉप्युलेशन असेल तर आपल्याला 15 केएलडीचा प्लॅन्ट असणं मिनिमम आवश्यक आहे. तर आपला इथे हा 15 केएलडीचा एफएसटीपी प्लॅन्ट आपण इन्स्टॉल केलेला आहे आणि यामध्ये आपण आपलं जे सेफ्टी मैला आहे त्याचे डिस्लजिंग इथे करतो. सध्या माझ्यासोबत इथले जे काम करतायत कर्मचारी आहेत आणि सध्या एक जो मैलाचा 3 केएलडीचा ट्रक भरून आणले आहे त्याचं आपण इथे डिस्लजिंग पाहणार. तर हा आपला स्लज ड्राइंग बेड जो आपण सेप्टेज इथे एम्प्टी करतो. तर या स्लज ड्राइंग मध्ये आपण सगळ्यात पहिले फ्लॅश पॅडवर तो स्लज टाकतो, त्यानंतर तो सेटल होतो स्लज ड्राइंग बेड मध्ये. आपण 15 केएलडीचा प्लांट आहे आपला. तर आपण दररोज 15,000 लिटर हा मैला इथे ट्रीट करू शकतो. तर इथे काय होतं की तो मैला पडल्यानंतर तो 8 ते 10 दिवस वाळवला जातो इथे आणि त्याचं जे इफ्लुएंट आहे ते वॉटर तर ते पुढे एबीआर मध्ये येतो. तो इथे आपण साधारण 8 ते 10 दिवस वाळवतो आणि तो मैला वाळल्यानंतर आपण तो मैला त्याच्यात काढतो आणि इथे ही जागा आहे, ही बाजूला जागा आहे. तर इथे आपण तो वाळलेला मैला इथे आपला जो आपण ड्राय स्लज टाकला 8 ते 10 दिवसानंतर काढतो तो इथे असा पूर्ण आपण टाकतो. 1-2 वेळेस पलटतो जेणेकरून त्याच्यातून पूर्ण पाणी निघेल्यानंतर एक निवड तिथे खत उरेल. तर ही ती जागा तिथे शेड नाहीये तर इथे आपण सगळा मैला टाकतो आणि त्याच्यानंतर खत आपण गोण्यांमध्ये भरून ठेवतो. आता आपली दुसरी स्टेप जी आहे ती एबीआरची अनरोबिक रॅपिड रिएक्टर. आपला तिथून जो इफ्लुएंट येतो एसडीबीचा, तर ते पाणी पाईपाद्वारे आपल्या एबीआर मध्ये येतं. एबीआर म्हणजे अनरोबिक रॅपिड रिएक्टर. तर रॅपिड रिएक्टर मध्ये आपण इथे पाणी बघू शकतो की आपल्या दुसऱ्या स्टेज मध्ये पाणी आपल्या एसडीबी मधून येऊन इथे पडतंय. तर या या पाण्याच्या एबीआर मध्ये हे पाणी 4 इथे चेंबर लावण्यात आले. तर या चार चेंबर मधून जो आपला सॉलिड पार्टिकल्स असतात, जो स्लज आपल्या पाण्यात मिसळलेला राहिलेला असतो, तो असा आपला खाली सेटल होत जातो. त्या पहिल्या चेंबर मधनं इथे येतो दुसऱ्या चेंबर मध्ये. पुन्हा दुसरा चेंबर पूर्ण भरला की ते ओव्हरफ्लो झालेलं वॉटर पुन्हा इकडे येतो आणि हा पूर्ण भरल्याच्या त्या चौथ्या चेंबर मध्ये आपलं पाणी येतं. ही झाली आपली एबीआरची स्टेज, एबीआरची प्रोसेस. यापुढे आपलं पाणी जातं पीजीएफ कडे, प्लांटेड ग्राउंड फिल्टर कडे. आपण इथे पाणी बघू शकतो. एबीआर मधलं जे इफ्लुएंट आहे ते इथे पडतंय, इथे पाणी. आणि इथे स्लोप असल्यामुळे हे पाणी या झाडांच्या, या प्लांट्सच्या खालून आपल्या पीजीएफ मधनं पास होतं. तर ही झाडं कर्दळीची आहेत. या झाडांमुळे ते पाणी अजून स्वच्छ व्हायला, त्याची सीओडी क्वालिटी चांगली व्हायला या झाडांमुळे मदत होते. ते पाणी या झाडांच्या खालून तिकडे पास होते. या झाडांचे आपण मेंटेनन्स चांगले ठेवले ते झाड हे बघू शकतो. प्रत्येक झाड हे व्यवस्थित प्लांटेड ग्रॅव्हल फिल्टरचे इफ्लुएंट आहे. तर हे पाणी आपण बघू शकतोय बऱ्यापैकी आता स्वच्छ झालेलं आहे या स्टेजला. तर हे जे पाणी आहे, हे पाणी आपण नंतर या पंपनी उपसतो आणि ते पाणी त्या टाकीमध्ये, ही जी टाकी आहे या पाणी, हे टाकीमध्ये पाणी स्टोर होतं. या टाकीमध्ये या टाकीतलं पाणी हे आपलं शेवटचं ट्रीट झालेलं वॉटर आहे आणि हे वॉटर आपण आपल्या बगीचाला आणि मळ्याला वापरतो. आपण या ठिकाणी काही सॅम्पल्स कलेक्ट केले. सॅम्पल मी सांगतो. पहिला सॅम्पल जो आहे आपला 1 नंबरच्या बॉटलमध्ये, तो आपला सेप्टिक टँक मधून घेतला. दुसरा सॅम्पल जो घेतला आपण, तो आपण आपल्या सक्शन ट्रक मधला सॅम्पल घेतलेला आहे. तिसऱ्या बॉटल मधला सॅम्पल जो आहे तो आपला, तो इन्फ्लुएंट आहे एबीआर मधला. चौथा सॅम्पल जो आहे तो आपला इफ्लुएंट आहे एबीआर मधला. पाचवा सॅम्पल जो आहे तो आपण पीजीएफचा इफ्लुएंट घेतलेला आहे, पीजीएफचा आउटलेट. आणि सहावा जो सॅम्पल आहे आपला, तो आपला आफ्टर क्लोरिनेशन ट्रीट झालेलं वॉटर आहे. आपण बघू शकता ते किती स्वच्छ वॉटर आहे, किती ट्रीट झालेलं वॉटर आहे. आणि ते आपण आपल्या वेगवेगळ्या पर्पजेस साठी वापरतो. झाडांना पाणी देण्यासाठी, बगीचाला पाणी देण्यासाठी, काही मळ्यांसाठी, ऍग्रिकल्चर पर्पज साठी हे पाणी आपण वापरू शकतो. अशा प्रकारे आपला एफएसटीपी हे आपला किती फायदा होऊ शकतो, म्हणजे वेस्ट टू वेस्ट हे आपलं होऊ शकते, ते इथे आपल्याला या पाण्याच्या स्वरूपात दिसतं.
Hello. Now, thank you for watching me and
Yes.
giving me an opportunity to. So, and thank you very much, madam.
Thank you so much, sir.
Yes, thank you.
Yes. So, participants, hello. Hello, participants. Today is our last day of the STP. Here, the second session of STTP is end up. But before end of this program, for success of this STTP, I would like to thank our Honorable Dr. Abhay Vaksar, Director of DT, Dr. Vinod Mohitkar sir, Director of MSBTE, Dr. A. Mark Chitlange sir, Secretary of MSBTE, to give us the permission for organize such a wonderful program. I sincerely thanks to Mr. Prithviraj Deshmukh sir, Chairman of SES, and Mrs. Vaishali Deshmukh ma'am, Secretary of SES, for giving such opportunity to us. I would like to express my gratitude to our principal, Dr. D.R. Suroshi sir, to encourage us constantly. I thank to Mr. Dattatreya Bangar sir, convener of STTP, to take this opportunity positively and do his team lead role in fantastic way. How I forget to my team. I would like to thank Mr. Abhijit sir, HOD of Automobile Engineering, for continuous helping us for technical support. This online program can't success without his technical support. Thank you so much, sir. I thank to Mr. Mayuresh Nayakwad, sir, for guiding us, correcting us, helping us to make this event successfully. I thank to my colleague Ms. Nazneen Daryavadi for handling the social media and also to coordinate with me. Also, I thank to entire teaching and non-teaching team of SIOT. I thank to our IF student Master Manas for handling technical facts from the day first. I thanks to all my participants who connected with us from last 5 to 8 days. Most of the participants connect through personal messages and share their experience with the appreciation comments. And finally, here I conclude the STTP on environment engineering for global sustainability is concluded. Thank you so much.